Hi, now I want to talk about Doorlock controller using one hot encoding for the states. As we see, as we move into larger finite state machines, our state tables can become quite large and cumbersome. And so there are ways that we can implement our controller without having to actually write out a full state table. One way to do that is to encode our states using one hot. If we take a look at our project, we see that we have 6 states and we have 5 inputs and 2 outputs, okay? And so with one hot encoding, we don't have to make a state table. We just have to talk about the idea of each state as far as how do we get there and how do we stay there. If we take a look at the state called start, we see that we can get there if we're in the wait state and S is equal to 1, or we can stay there if we're in the start state and A is equal to 0. Likewise, we can get to the red 1 state if we're in the start state and A or B naught G naught is asserted. And we can stay in the red 1 state if we're in the red 1 state and we get A naught. And so there are obviously each path, each transition line tells us exactly how we can get to a state or how we can stay in a state. And so we're going to use that knowledge to write our equations. If we go to Model Sim, okay, and so once we've opened up our project, here I have a new project called Doorlock One Hot, just to differentiate it between our last project, the project that I used for just binary encoding for this particular lab. I used Doorlock One Hot for this project. And so taking a look at the .v file that's associated with this is Doorlock One Hot combinational. I want to write my equations for each state. And so notice, first of all, in order to do this, I have to have more flip-flops. I have to use a flip-flop for every state. Since I have 6 states, notice with this particular encoding, I now have 6 flip-flops that are associated with states. So my input has 6 flip-flops. My output has 6 flip-flops, state and next state, each using 6. The encoding that I'm going to use, I have a reset that I have to keep because all of the flip-flops are all set to 0 initially. But each state then is encoded. And notice with each state, only one flip-flop is equal to 1 at a time. And so if that flip-flop is equal to 1, I know that I'm in that particular state. Like here, if flip-flop 5 is equal to 1, I know that I'm in the red 2 state. Alternatively, if flip-flop 0 is equal to 1, I know I must be in the wait state. And so I can use that rather than having to have a long string of values, state 5 not, state 4 not, state 3 not, state 2 not, state 1 not. I just have to say if state 0 is equal to 1, then I must be in the wait state. Taking a look at some of the equations, again, I don't have to make a state table, but I have some equations here that I could show you. So let me set those up. Okay, without giving everything away, because I want you to have to do some thinking in this lab. Here I have next state 1, which is basically the start state. I know that next state 1, how do I get there? I get there if I'm in state 0, which happens to be the wait state, and S is equal to 1. And then how do I stay there? Well, if state 1 and with not A. Taking a look at our original design, we see that here, state 1, I get there if I'm in the wait state and S is equal to 1, or if I'm in the start state and A is equal to 0, I stay there. And so you're going to write that for each equation and for each state. And so basically having an equation for each one, then you'll have to write an equation for wait, and obviously it's going to have 5 inputs based on the other 5 states, as well as the value for being in the wait state and S is equal to 0. So after you have that, you can go ahead and continue on. Okay, and once you've created your .v file for your combinational logic, just go ahead and make a symbol, as I've done here. I have my Doorlock One Hot combinational. My symbol It has inputs for the states that are 6 bits wide and outputs for the next state that are 6 bits wide. Okay, has all of the inputs for each of the colors, R, G, and B, as well as A being that input to say that a button got pressed. Don't forget to include your finite state machine circuitry here for A. This was, we did the finite state machine controller for A in class, and so basically we have our little controller to just output an A, so that we only see an input once per clock cycle, or only lasts for 1 clock cycle. So once we have that, we have our finite state machine BDF. We can go ahead and run model sim on this particular project. And so
okay, so we have with model sim for the one hot encoding many of the same tests. Notice here we're checking all 6 of the flip-flops for our states, and we have each of the test names we can see here, SRG, SRAB, and so you can see there are lots of tests, basically 200 tests that I test for with this particular lab. Okay, and that's for one hot. We have all of our inputs, we have our outputs, including our next states, and W and U. So make sure that you get all tests passed with that, and then you can go ahead and create a symbol of your Doorlock FSM. All right, so once we've returned to, we've run model sim, and we've returned back to Quartus 2, we can go ahead and create a symbol of our Doorlock FSM BDF, and then add a new schematic. We have a new schematic from there. Sorry, we want new, and then a new schematic file. Click on that, and then we can call it Doorlock One Hot, which I've done. I've added the button debouncers, and I have my Doorlock FSM symbol that I've created. I have my outputs, which are all buffered using the alternate out buffer, and then we see that by using the QSF we have all of our input and output switches. It is your choice. The QSF file is set up for either the push buttons or the switches. Taking a look at it, you can choose. The top ones are the switches. We have our switches here. You can use those. I just have mine set to switches. Alternatively, if you want to use the push buttons, you can use the push buttons for your inputs. So there they are. Just change, just uncomment these out and comment these in, and you'll be fine. Notice I have the names here. Since I wanted to do 2 different things, I happen to use the switch for the name. Okay, your choice as to which you prefer to set up. And so once you've done that, you can go ahead and program your board and check out Doorlock. Okay, thanks for watching.